When we look up at the night sky, glittering with stars, it is easy to imagine the universe as a quiet and orderly picture, where every star and every galaxy drifts peacefully along its own path in perfect harmony. But that is only an illusion created by human perception. Through the lens of modern astronomy, the universe is far more violent and dynamic than it appears. In dimensions of space and motion that the naked eye cannot sense, our Milky Way is not a calm galaxy at all. It is a galaxy in relentless motion, more like a cosmic predator than a peaceful island of stars, slowly devouring and absorbing smaller satellite galaxies. At least 6 galaxies have already fallen victim to it, and even today, the remains of a seventh still linger around the Milky Way, like debris from a colossal collision that has not yet fully faded away. For more than a decade, the Gaia Space Telescope has quietly scanned the sky, collecting and processing vast amounts of data with an unprecedented level of precision. From that enormous body of information, a strange and astonishing truth has emerged. We are not simply living inside a galaxy. We are living inside the aftermath of giant galactic mergers, where the remnants of swallowed galaxies still preserve the scars of ancient collisions. The Milky Way is not easy to observe directly. Its central region is so densely packed with stars, nebulae, and enormous clouds of gas and dust that it forms a natural curtain astronomers call the zone of avoidance. Visible light is almost completely blocked in this region, making direct observation of the galactic core extremely difficult. Because of that, our understanding of our own cosmic home has sometimes been more limited than our understanding of the Andromeda galaxy, even though Andromeda lies millions of light-years away. Distance is another major challenge. In space, a star may appear dim because it is small or because it is incredibly far away. This ambiguity makes even the basic question of how many stars the Milky Way contains surprisingly hard to answer. Current estimates range from 100 billion to 400 billion stars, an uncertainty large enough to span a factor of 4. Gaia changed that. It relies on one of astronomy's most powerful tools for measuring distance, parallax. You can experience the basic principle yourself. Hold up a finger in front of your face and close one eye, then the other. Your finger seems to shift position relative to the background. That apparent shift is parallax. With human vision, the effect comes from the small distance between your eyes, about 6 centimeters. Gaia applies the same principle on a vastly larger scale. Instead of using the distance between two eyes, it uses the full diameter of Earth's orbit around the Sun, roughly 300 million kilometers. From one side of Earth's orbit, Gaia observes the sky. 6 months later, when Earth is on the opposite side of the Sun, it measures the same stars again from a completely different angle. The tiny change in a star's apparent position against the distant background allows astronomers to calculate its distance in three-dimensional space with remarkable accuracy. Equipped with a camera system of nearly 1 billion pixels, Gaia became one of the most precise observing instruments ever sent into space. Over more than 10 years of continuous operation, it has carried out roughly 3 billion measurements and built an extraordinarily detailed three-dimensional map of around 2 billion stars in the Milky Way. This is not just a technological achievement. It is a revolution in how humanity understands the structure and dynamics of the galaxy we live in. In 2018, Dutch scientists analyzing Gaia's second major data release noticed something deeply strange. Among 7 million stars tracked in high detail, about 30,000 were moving in the exact opposite direction from the majority of stars around them. It was as if a stream of cars had suddenly appeared racing the wrong way down a highway. These stars were not only moving differently, their chemical fingerprints were different as well. Spectroscopic analysis showed that their composition did not match that of the Milky Way's native stellar population. Scientists quickly realized that these stars did not originate in our galaxy. They were the remains of an outside galaxy that had been swallowed long ago. Using supercomputer simulations, astronomers reconstructed the catastrophic collision that likely took place about 11 billion years ago. The victim was a dwarf galaxy with a mass about 1/4 that of the Milky Way. It plunged into our galaxy and was torn apart by gravity. Its original structure was destroyed, and hundreds of millions of its stars were captured and scattered into the halo of the Milky Way. But that discovery was only the beginning. As the Gaia data was studied more deeply and more comprehensively, scientists came to realize that the merger history of the Milky Way was far more dramatic than anyone had imagined. By 2022, once the most important datasets had been processed, the conclusion had become clear. The Milky Way had absorbed at least 6 other galaxies in its past. Today, those galaxies no longer exist as separate structures. Their stars have been completely mixed into the Milky Way, becoming part of the galaxy we now call home. Every point of light in the night sky could be the living remnant of an ancient world that once existed independently before being pulled into the Milky Way's gravitational grasp. If those ancient mergers can now only be detected through faint traces left behind, the fate of the Sagittarius Dwarf Galaxy is different. It is not just a relic of the past. It is a cosmic collision still unfolding in real time. This unlucky neighboring galaxy is the seventh known galaxy currently being absorbed by the Milky Way, a vivid reminder that galactic interactions are not ancient history. They are still happening. For roughly the past 5 billion years, the Sagittarius Dwarf Galaxy has repeatedly plunged through the spiral arms of the Milky Way. Each passage has torn away more of its structure under the force of our galaxy's gravity. Thousands, even millions, of stars have been stripped from it and stretched into vast stellar streams that wrap around the Milky Way. These star streams are the visible traces of a slow but unavoidable destruction, where a smaller galaxy is gradually being pulled apart and assimilated into a larger one. This collision may not only be destroying the Sagittarius Dwarf Galaxy, it may also have shaped our own existence. Some scientists suspect that around 4-6 billion years ago, Sagittarius's interaction with the Milky Way triggered powerful shock waves in giant clouds of gas, causing one of them to collapse and ignite the birth of our sun. In other words, without this galactic interaction, humanity itself might never have existed. Gaia has not only revealed the Milky Way's long history of collisions, it has also transformed our understanding of the solar system. The mission has determined highly precise orbits for more than 150,000 asteroids, small bodies that still preserve important clues about how the solar system formed. By carefully tracking subtle irregularities in their motion, Gaia found that at least 352 of these asteroids may not be alone. They appear to have their own moons, forming binary asteroid systems. This discovery doubled the number of such systems previously known, and showed that the solar system is far more dynamic and complex than older models had suggested. In deep space, Gaia also identified a previously unknown black hole called Gaia BH3. With a mass about 33 times that of the Sun and a distance of roughly 2,000 light-years from Earth, it stands out as a giant among stellar mass black holes in the Milky Way. Most known stellar black holes in our galaxy are only around 10 solar masses, so this discovery showed that much more massive examples can exist much closer to us than many astronomers expected. Gaia has also produced the largest three-dimensional map of quasars ever created, identifying around 1-3 million of them. The light from the most distant of these quasars began its journey when the universe was only about 1.5 billion years old, since the age of the universe is currently estimated at about 13.8 billion years. That means these quasars formed during the early stages of cosmic history. This 3D quasar map helps astronomers understand the large-scale structure of the universe and provides crucial data for studying cosmic expansion and the distribution of matter and energy across space. From overturning our old image of space as quiet and still, to revealing the Milky Way's violent history of collisions, from mapping 2 billion stars in 3D to discovering asteroid moons, giant black holes, and huge numbers of quasars, Gaia has opened an entirely new window onto the universe through more than a decade of observation. It has shown us that the universe was never truly peaceful. It is full of motion, upheaval, collision, and transformation, and it is precisely through these turbulent events that the star-filled sky we see today came to exist. So the next time you look up at the night sky, you may see it differently. Hidden among those points of light may be the remnants of ancient galaxies the Milky Way consumed long ago. Those stars that seem so still are in fact moving at extraordinary speeds, obeying the deep laws of a restless universe. And Gaia's work is still continuing. In the future, it may reveal even more secrets about the cosmos. Humanity's journey of discovery will not stop either. Step by step, we continue breaking old assumptions, building new understanding, and searching for meaning and direction in a universe that never stands still.